This question is asked in GATE 2002, and if you observe this one, it is about recurrence relation. See this, the solution to the recurrence relation, and the recurrence relation is given here. Till now, even in Master's theorem also, we have seen the questions in which t of n equal to t of n by 2 or something like t of n minus 1, something like this. But then here if you observe it, it is in exponentiation, like t of 2 power k. So before answering this particular question, I want to discuss about how to solve such questions using Master's theorem if the options are given in big O notation or theta notation. In case if this question would have been asked in order to apply the Master's theorem and the options would have been given in big O or theta, we have to solve it in a different method. Let's solve those questions. I'll just explain that here, and then we can come back and solve this one as well. Okay, so what I mean to say is, whenever this question is given and the options are in big O or theta, then try to transform it. So one way of solving it is, again I am not solving this question, I am solving another question. Okay, in case if the options would have been given in theta or big O, now you try to solve it in such a way that we can apply Master's theorem. If you look at this directly, we can't apply Master's theorem, isn't it? So in order to apply Master's theorem, I am just substituting like this: let 2 power k equal to n. Therefore this factor becomes n. Now if the right hand side, if you see, it is 2 power k minus 1, then what happens to 2 power k minus 1? 2 power k minus 1 is nothing but 2 power k divided by 2, and now already we have assumed that 2 power k equal to n. Therefore this one will become n by 2. If 2 power k equal to n, 2 power k minus 1 will become n by 2, right? Now you substitute it there, then what happens? The equation will change to t of n equal to 3 into t of n by 2 plus 1. Now this is in a format where you can apply Master's theorem, right? Now after applying Master's theorem, you will get some answer, right? In this case what happens is, you are supposed to find out n power log a base b, and you are supposed to compare with this f. So if you see this, it is going to be n power log 3 base 2, isn't it? Just check that. It is going to be n power log 3 base 2, right? And this one is going to be 1, and obviously this one is greater as the function, right? If you compare both these functions, this one is going to be greater. Therefore the option, the answer according to Master's theorem is order of n power log 3 base 2, isn't it? Now you have to convert it back again into the given like that. In case of 2 power case, we have to convert it like this, so n is not allowed there. So what do you get? So we got that t of n equal to so and so. Now how can I convert it back? Anyway, this one is t of 2 power k. In place of n I am substituting 2 power k, right? And here also you are supposed to substitute 2 power k. Big O of 2 power k log 3 base 2, right? Now if you observe it, you can take k here, right? Then what does it become? 2 power log 3 power k base 2, and this entire number according to logarithms you can write it as 3 power k. Therefore answer is big O of 3 power k. So if you observe it, the answer is going to be this one. B is the option, right? So this is how you can solve it whenever powers are given using Master's theorem. But this is not the question. Question is, they don't want either big O or theta. Anyway, if you see the question, there is no other term which is closely related to 3 power k. Only this one is there. Therefore this one is going to be option B. But then what they need here is exact solution. Now we shall solve this. We shall find out what the answer is. You got this? So what I was explaining here is not this question. In case if this question would have been asked by giving big O's or thetas here, then we can apply Master's theorem using this transformation, right? And it is a most frequently asked model, so please make a note of it. And now let's try to answer the given question without actually solving it. That is what I was saying. In recurrence relations, whenever you try to solve the questions, there is no need of actually solving them. You can use the elimination method. Let's try to do that method. Now see this one. T of 2 power k equal to something is given, and this is and these are the options, right? Now let's see, and also it is given that T of 1 equal to this one 1. So what are the options? If you want to evaluate, A is given as T of 2 power k equal to 2 power k. This is the meaning of it. Solving the recurrence equations means the left hand side is equal to this one. That is the meaning of it. And B is T of 2 power k equal to 3 power k plus 1 minus 1 divided by 2. And C is T of 2 power k equal to 3 power log k base 2. And D is T of 2 power k equal to 2 power log k base 3. Why am I writing all the options again is, many people get confused and they try to write T of k equal to this one, T of k equal to this one. No, it is not right. So if you are trying to solve this recurrence equation, and if it is given that the recurrence solution is this, it means that the left hand side is equal to one of them, right? It is not that T of k equal to one of them. Now if you can understand this, you can directly use the substitution method and solve it. Now say this, T of 1 equal to 1, that is what we already know, right? Now how do we get T of 1? If we have to get T of 1, then in place of k we are supposed to put 0. Now try to put 0 here. T of 2 power 0 is nothing but T of 1 equal to equal to 2 power 0, which means it is 1. So according to the this equation, T of 1 equal to 1, the first option seems to be right. We cannot eliminate it. Now let's talk about the second option. T of 1 means T of 2 power 0. So which means I am evaluating all these options by putting k equal to 0. Because if I put k equal to 0, left hand side will become T of 1, and now right hand side should evaluate to 1. That is its meaning. Now when I put k equal to 0, what happens here? T of 1 equal to 3 minus 1 by 2. 3 minus 1 is 2, 2 by 2 is 1, therefore option B is also valid. Now if you try to put k equal to 0 here, then left hand side becomes T of 1, but in the right hand side it is invalid because log 0 is not defined, therefore it cannot be the answer. And if you try to put k equal to 0 here, left hand side becomes T of 1, but right hand side becomes invalid because we cannot put k, log 0 is not defined, so not possible. Now what about A and B? Now we can put A and B. So let's try A and B here. One of them have to be eliminated. So in order to do that, I want to try with one more value. Now I want to see what if I put k equal to 1. See this, see that equation. If I put k equal to 1, it becomes T of 2 equal to 3 into T of 2 power 0 plus 1, which is nothing but 3 into T of 1 plus 1. So what is 3 into T of 1? T of 1 is nothing but 1. So therefore it is 4. So T of 2 has become 4. Right? Now if I substitute k equal to 1 in both of these, only one of them is supposed to give me the answer 4. If both of them gives me the answer 4, again I have to go on substituting more values. Right? Let's see this. Now let me put k equal to 1. If I put k equal to 1, what happens to option A? T of 2 equal to 2. But then here T of 2 is supposed to be 4. Therefore A is not the answer. So definitely B must be the answer. You can substitute it and check it, otherwise you can directly declare it. Say this. How can B be answered? T of 2, which means in place of k I am putting 1, equal to 3 of 1 plus 1 minus 1 divided by 2, which is 9 minus 1 divided by 2, 4. Got it? Therefore the answer is 4. Accordingly, right, here it is supposed to be 4 and we got 4. Therefore the option B is valid. So you need not solve it. By substituting method you can get the answer. But anyway, if the same question is asked for Master's theorem, you try to substitute these numbers with some other thing and then you get it, right? Let 2 power k equal to n, like this. And sometimes they will also ask you something like this. t of root n equal to something, right? Then here in this case, what do you do is let n equal to 2 power k you substitute. Then here what happens is, are you getting it? See, let us say some other question is asked like this: t of n equal to t of root n plus 1, something like this. Then what you do is let n equal to 2 power k, then you substitute it over there. Then we get t of 2 power k equal to 3 into t of 2 power k by 2 plus 1, right? Now if you assume that this is a function of k, then this is a function of k by 2, isn't it? Then you can write like this: f of k equal to 3 into f of k by 2 plus 1. Done, isn't it? Now you can apply Master's theorem, and from Master's theorem you can find out that f of k equal to big O of log k, big O of k power log 3 base 2, k power log 3 base 2, right? And then you can convert it back appropriately and you can get it. Therefore, using these substitutions you can solve all such questions, right?
Hi, if you are planning to do masters, then doing masters abroad is better than doing masters in India. I'll give you all the reasons. So, first reason is, out of 1 lakh students who take GATE every year, there are only 500 seats in old IITs. So all the IITs put together have an acceptance rate of 0.5%, and IITs, universities better than IITs, they have very good acceptance rate like 30%, 40%, but all the IITs put together have an acceptance rate of 0.5%. And if you are working hard to get into IIT Bombay's ranking is 177 and IIT Roorkee's ranking is 400. If you are happy to get into IIT Roorkee, then getting into universities better than IIT Roorkee is easier compared to getting into IIT Roorkee. And looking at the salaries for computer science, for software jobs, if you have done your masters in computer science in US, the salaries are ranging from 80 lakhs per year to 1.2 crore per year. So even if you take an average of 1 crore per year, your savings will be much higher than the salaries in India. After taxes and your cost of living, you can easily save 40 to 50 lakhs per year. And in India, the maximum jobs that you get is around 30 lakhs. So your savings will be much greater than the salaries in India. And these are all the services that we provide. University shortlisting. So depending on your profile, we will shortlist what are the universities that you have to apply, and statement of purpose building, and then LOR guidance, and GRE and English test assistance, and education loan assistance. So you don't have to have any collateral, which means without any security, now you can get education loan. Getting education loan is very simple these days, and whatever the amount of fee that you have a range of universities. You can apply for 10 lakh universities, 20 lakh universities, or 50 lakh universities. But whatever it is, you are going to get complete education loan, and you can pay off your education loan in 1 year after you get a job. And then we do visa assistance, mock visa interviews, and then connecting with the university alumni. So now you might ask why we should join Game of Visas. So the answer is we have 90% success rate, 99% success rate. And these are all the destinations that we guide the students to. So we guide students to any country that you want to go. So now it is not just USA. We guide to UK, Germany, Australia, Canada. So we guide students to all the countries. We work with all the destinations. And if you are interested in going abroad, you have to just drop us a message on this WhatsApp number 9494 555 454. Okay, thank you.